let's take some notes for day 2, or 6.2, properties of rational exponents. We're going to start with adding and subtracting like radicals. Alright, simplify. Example 1. We've got the 4th root of 10 plus 7 times the 4th root of 10. So when we're adding and subtracting like radicals, it is exactly the same as combining like terms. We have the exact same radical here, the 4th root of 10, and we have the 4th root of 10 here. When you have exactly the same, again, it's just like combining like terms. Remember the coefficient that's secretly in front here. It is a 1. So essentially what we have is 1 plus 7. So that'll give me 8 4th roots of 10. Example 2, we've got 2 times 8 to the 1/5 power plus 10 times 8 to the 1/5 power. Again, same thing as combining like terms. We're going to pretend that this is x. They are both exactly the same. So you basically just add the coefficients. 2 plus 10 gives me 12 times 8 and 1/5. If the two last names, if you will, if the last names are not exactly the same, you cannot add them. That would be like adding x squared plus x. We cannot do that. They have to be exactly the same. You combine like terms. Example 3. We've got the 3rd root of 54 minus the 3rd or cube root of 2. So again, remember I said these have to be exactly the same for us to be able to add or subtract them. These cube roots are not the same. We have the cube root of 54 and the cube root of 2. They are not the same. We cannot subtract them. What we can do is try to break 54 down. The cube root of 54 can be simplified. 54 breaks into 2 and 27. Now remember the shortcut that I taught you based on factoring. If either one of your terms is a perfect cube, you don't have to factor anymore. 27 is a perfect cube. The cube root of 27 is 3. So that gives me 3 cube roots of the only factor that's left, which is 2. So I've got this is the same as this, 3 cube roots of 2 minus the cube root of 2 right here. Now, since my radicals are the same, I have a cube root of 2 and the cube root of 2. Those are like terms. I can combine them. 3 minus 1 gives me 2 cube roots of 2. Okay, example 4. I've got the cube root of 5 plus the cube root of 40. Again, we cannot add these because our cube roots are not exactly the same. What we can do is try to simplify 40 and see if that allows us to be able to add the 2 roots. So 40 will break into 8 and 5. Now remember, if either one of these terms are a perfect cube, you can go ahead and take it out. 8 is a perfect cube. So this is going to give me, I'm going to rewrite this. So I've got the cube root of 5. And I'm going to add the cube root of 8 is 2. And what I have left underneath the radical is the 5. So I've got a cube root of 5 plus 2 cube roots of 5. Those are like terms. I can add them together. That gives me 3 cube roots of 5. If you want to go ahead and take these further down instead of stopping where I did, you will still get the same answer. For example, 40, that splits into 2 and 20. 20 splits into 5 and 4. 4 splits into 2 and 2. So I've got 2, 5, 2, and 2. Knowing it was the cube root, I had to have triplets, and I do. There's 3 2's right here. So that came out, and the only thing that was left in the radical was the 5, which was here. No matter how you factor it, you should still get the same answer.